Hello students. In the last class we have completed one of the important chapter from your inorganic syllabus, that is P block elements, and we have seen some of the important concepts as well as the important questions for annual examinations also. And further we'll go with one of the important chapter, that is in case of organic chemistry. Already we have completed two chapters. One is haloalkanes and haloarenes. Second one is alcohols, phenols and ethers also we have completed. And now we'll move on to the third chapter as well, as it is an important chapter for your examination, and they haven't removed any kind of concepts from this chapter, which means the complete chapter is for your syllabus and for the sake of examination also. And this chapter, it is generally for the functional group, study of functional group, that is aldehydes, ketones and carboxylic acids. Here there are three different concepts. One is aldehydic functional group, second one is ketonic group, third one is carboxylic acid. And in this chapter we'll study about the general information about the functional groups, along with the nomenclature, along with the structure of molecule, as well as physical properties, chemical properties and uses. The same thing is studied even for aldehydes, ketones as well as carboxylic acids. And now we'll start with the aldehydes first, right? So, and first we'll get the basic information. What is the main difference between the aldehydes, ketones and carboxylic acid? Generally, the organic compounds which consist of a carbon-oxygen double bond. So if you go through the carbon-oxygen double bond, then carbon is double bonded with oxygen, and from other two sides it can be bonded with any kind of the alkyl or aryl group, right? And these type of compounds are generally called as the carbonyl groups. The carbon-oxygen double bonded compounds are generally termed, or they are given the name that is carbonyl groups, right? So in aldehydes, in specifically if you take the aldehydes or aldehyde group, in aldehydes the carbonyl group is bonded to the carbon and hydrogen, which means already the carbon is one side double bonded with oxygen, which means carbon has a maximum 4 valency. So if you observe, carbon is bonded to, there is 4 bonded. Let's say the carbon which is double bonded with oxygen, generally we'll call it as a carbonyl group. If this carbonyl group further bonded to carbon and hydrogen, if it is further bonded to carbon and hydrogen, then this molecule is generally termed as aldehydes. Therefore, the aldehydes are the class of compounds in which the carbonyl compound or the CO double bonded compound is further bonded with carbon and hydrogen, right? So this is in the form of C double bond O, one side bonded with the alkyl group R and another side bonded with the hydrogen, right? And if you compare the aldehydes with ketones, in ketones what happens? The carbonyl group, it is bonded with the 2 carbon atoms, right? So it may be alkyl or aryl, right? So observe the difference. Here there is bonded with one alkyl group or aryl group and another one is hydrogen atom. But in case of ketones what happens? It is generally bonded with 2 carbon atoms, right? So which may be alkyl or aryl, which means there is no any presence of hydrogen in case of a ketonic group, right? So since the carbonyl group is nothing but carbon and double bonded with oxygen, it is further double bonded with the alkyl group. That is, both may be alkyl, both may be aryl, or one may be alkyl or aryl. But if you go for that is carboxylic acid group, right? So in case of carboxylic acid, what comes? So here the carbonyl compound in which the carbonyl group is bonded to oxygen. If you observe here, the carbonyl group is bonded to oxygen, and these are known as carboxylic, right? So here it is in the form of OH, that is OH group, that is hydroxyl group, which is bonded to the carbonyl group, and one side it is bonded with the alkyl group, right? So therefore it is in the form of RCOOH, right? So it is in the form of RCOOH. And this aldehyde, it is in the form of RCHO, that is in the form of RCHO. And this ketonic group is in the form of RCOR dash. It is in the form of RCOR dash, right? So that is the main difference between the aldehyde group, ketonic group and carboxylic acid group, right? So the main difference are in all the aldehydes, ketones and carboxylic acid function group, the main important thing is carbonyl group. And this carbonyl group, if it is bonded with carbon and hydrogen, then it is called as aldehyde group. If it is bonded with both the alkyl or aryl group, then it is called as ketonic group. And if it is one side bonded with the OH group and one side bonded with the alkyl or aryl group, then it is called as a carboxylic acid group. And further, if you see the carbonyl compounds in which carbon is attached to nitrogen, if it is attached to nitrogen and halogens, are generally called as amides and acid halides. Right? So if the carbonyl group is bonded to halogen atom, it is called as acid halides, and if the carbonyl group is bonded to the nitrogen group, then it is called as amides. Here if you observe, the carbonyl group which is bonded to NH2, it is called as amide. The carbonyl group which is bonded to the halogen, right? So here C double bond O, one side bonded with R, one side bonded with X, right? So this is called as acyl halides, where X is the halogen, that is generally called as acyl halides. X may be any kind of halogen, it may be chlorine, fluorine, bromine and iodine. Similarly, here you can observe that is R C double bond O, in which oxygen acts as a bridging bond between two compounds, right? So these are generally called as acid anhydride. These are generally called as acid anhydride. And if the functional group which is made up of RCOO dash, right? And this is generally called as esters, right? So RCOO dash is esters, RCOR dash, that is ketone, right? So that is a major difference between the ketones as well as the esters. And there are some important points, that is aldehydes and ketones as well as carboxylic acids are important for a biological process, that is biochemical process in the atmosphere which takes place in plants and animals also, that is biochemical process. And they add fragrance and flavor to the nature. In case of nature or environment, the fragrance of some kind of plants, that is, or the flavor similar to the clove, right? So different kinds of the materials or the substances which are used for cooking food, right? And those are generally made up of the natural things which are known as aldehydes, ketones and carboxylic acid. And they are also used in many food products that I already said. They are mainly used in case of food products and pharmaceuticals, generally in the preparation of drugs, and generally in case of drugs are generally nothing but medicines, in the manufacture of medicines. So these aldehydes, ketones and carboxylic group are used. And even in the manufacture of paints, adhesives and perfumes, as well as plastic and fabrics. So in the manufacture of paints, adhesives, perfumes, as we say that, so these are having the fragrance and good odor are generally called as fragrance and flavors. So these kind of molecules are generally used in the manufacture of paints, adhesives, right? So like gum, and even in the manufacture of perfumes, plastic, and even in case of fibrous, right? So that is fabrics also, we can use this different kinds of functional group like aldehydes, ketones and carbon, right? So that is the general information about the aldehyde, ketones and carboxylic acids. Further, if you go with the nomenclature of aldehydes and ketones, the next important part is nomenclature, which is nothing but naming the functional group like aldehydes and ketones, right? So generally, aldehydes and ketones are often called by their common name instead of IUPAC, right? So we know UPAC system of naming of different compounds, but the aldehydes and ketones are generally named on the basis of their common name instead of UPAC name or IUPAC name. And the position of the substituent, whatever might be the substituent, that the position of that substituent in the carbon chain is indicated by the Greek letter alpha, beta, gamma, delta, so on and etc. Right? So here if you observe some of the examples in which we can say the substituent on the carbon chain, so it is based on the number of carbon atom, it can be given as alpha, beta, gamma and delta. Right? So it is a CS3CHO, right? So CS3 which is bonded to CH2 is generally called as acetaldehyde, generally termed as acetaldehyde. This is the common name. And benzene which is bonded with the aldehyde group, right? So here if you observe benzene which is bonded to the aldehyde group, we'll call it benzaldehyde, generally called as benzaldehyde. And here if you observe CS3, CH, CH2, C double bond OH, right? So that is CHO group, that is aldehyde group at the end. And here if you number from right, so this is the longest parent chain, right? So you already know the nomenclature, how it is done, even in case of first PUC you have learned. So it is a functional group and we have to start from this side. This is the first carbon atom, second carbon atom, third carbon atom. First carbon atom is always alpha, which is directly bonded to the functional group, and next to that will be the beta, next to that will be the gamma, right? So therefore here the substituent, that is Br, that is nothing but the halogen, that is bromide group, that is bromine group, right? So which is bonded with the carbon that is next to the first carbon, right? So the bromine or the bromide molecule is generally bonded with the carbon right? So which is next to the alpha carbon. This is alpha carbon atom. So this is beta carbon atom, right? So here I can represent it. So this is the alpha carbon atom. This is the beta carbon atom. This is the gamma carbon atom, right? So therefore, so here if you observe, this bromine is bonded with the beta carbon atom, and therefore it is called as beta bromo butyraldehyde. Butyl, because the carbon atoms are 4, 1, 2, 3, 4. If there are 4 carbon atoms, generally we call it as butane, right? So further it is bonded with the aldehyde group, right? So here if you divide, you will get 4 words. One is beta, bromo, there is a bromide group, and butyl, right? So that is a butyl plus aldehyde. Generally you can call it as beta bromo butyraldehyde. Beta bromo butyraldehyde, right? So like this, the position of the substituent in the carbon chain indicated by the Greek letter, right? So that is alpha, beta, gamma as well as delta, so on. And the common name of ketones is derived from the naming the 2 alkyl or aryl group, right? So the common name of ketones are derived by naming 2 alkyl or aryl groups bonded to the carbonyl group, right? So which is further bonded to the carbonyl group. Here if you observe, CH3, C double bond O, CH3, right? So both sides it is CH3, in between there is a carbonyl group, right? So and it is generally called as acetone. Common name of CH3COCH3, that is acetone. And here if you observe the benzene ring, which is bonded to C double bond O, further bonded to CH3, that is generally called as acetophenone. The common name of this molecule is acetophenone. And if 2 benzene rings are bonded in between if there is a carbonyl group, right, which connects the 2 benzene rings, that is generally called as benzophenone. Right? So these are some of the important common names of aldehydes as well as ketones. So further if you go for the IUPAC name, that is UPAC system of naming, generally it is derived from the name of the alkane. It is derived, which means taken from the name of the alkane itself, by replacing, this is very important, by replacing the ending letter or ending alphabet E with Al for aldehyde. For aldehyde, you have to remove, if it is alkene, you'll make it as, right? So you have to remove this E and you have to fix the word al, right? And in case of ketones, what you have to do? You have to remove this E, right? So, and this alkane E is removed and ON is substituted, right? So that is respectively for aldehydes as well as ketones, which means if there is an E in case of any alkyl group, so E is replaced and Al is connected for aldehyde group, and E is replaced and ON is connected for ketonic group, right? So if you see 2 to 3 examples, you can understand very easily, right? So here if you observe CH3CHO, there is aldehyde group which is bonded to the CH3. So generally in common system or in common name, it is called as acetaldehyde. Already we have seen the acetyl group which is bonded with aldehyde, we will call it as acetaldehyde. But in case of IUPAC, it is called as ethanol, right? So this Al represents the aldehyde group, right? So this Al represents the aldehyde group, right? So that is ethane, right? In which one hydrogen is replaced and it is bonded with CHO group, right? So that E, ending letter E is replaced with Al. Here also if you observe, there is CH3, CH2, CH2, CH, CH, CH2, CHO, right? So here if you observe, first carbon atom, second carbon, third carbon, fourth carbon, fifth carbon, sixth carbon, which means for fourth carbon that is a bromo group as attached, so there is 4 bromo, and third carbon atom that methyl group is attached, 3 methyl, 4 bromo, 3 methyl, heptanol, 1, 2, 3, 4, 5, 6, 7, right? So that is 7 carbon atom. So 7 carbon atom is generally called as heptane, but here the word ending with E, heptane means HEPTANE, that E is replaced with Al if it is bonded with the aldehyde group. Therefore here I have mentioned the Al. Understand, this is very important, right? So when you are writing the IUPAC name of the aldehyde group, the ending letter E, right? So ending letter E for the carbon chain is replaced with the Al, it is al group. And similarly here if you see, right? So the cyclohexane which is bonded with the aldehyde group is generally called as cyclohexane carbaldehyde. Cyclohexane carbaldehyde. Similarly, right? So cyclopentane, which is one side bonded with double bonded with oxygen and another side is bonded with the CH3 group. Here if you observe, this is the first group, second group and third group, right? So therefore you can call it the first carbon atom, second carbon atom, third carbon atom. So therefore that is 3 methyl, that is cyclopentane. 3 methyl cyclopentanone. And here also if you observe, that is a CS3, CS2, C double bond O, CS2, C double bond O, H. It is aldehyde group which is bonded with this chain. And here if you observe, first carbon atom, second carbon atom, third carbon, right? So 3-oxy, right? So this is 3-oxy pentanol. 1, 2, 3, 4, 5. There are 5 carbon atom. We can call it as 3-oxy pentanol. And here if you observe in this fourth example, so that is pentane. This is generally pentane. Since there is an attachment of, right? So since there is an attachment of the ketonic group, it is generally called as one, pentanone, right? So the E is replaced with ONE. That only we have studied here. In case of IUPAC names, the ending letter E or ending alphabet E is replaced with al, and in case of aldehydes. But in case of ketones, what we have to do? We have to replace this E with ONE. We have to replace that with ONE. Structure of carbonyl group. The next concept is structure of carbonyl group, right? So the carbonyl group is nothing but the carbon which is double bonded with oxygen, right? So here, so I'll do some rough work here for your understanding. So here if the carbon is double bonded with, right? So generally carbon has 4 valencies. You can observe this one. And the carbonyl group is nothing but the carbon which is double bonded with oxygen, and further it can bond with any of the alkyl or aryl group, right? So here the carbon atom is sp2 hybridized, right? So this carbon atom is sp2 hybridized, right? And it forms a 3 sigma bond, right? So this is the first sigma bond, second sigma bond, and the third sigma bond, right? So single bond are considered as the sigma bond, right? So therefore carbon has 3 sigma bonds, right? So one is double bonded, therefore one is sigma as well as pi bond. Along with that there are 2 sigma bonds. So therefore it consists of 3 sigma bonds and it consists of 1 pi bond. Since it is double bonded, it is 1 pi bond, right? So if all are sigma bond, if all are single bonded, then we can call it as 1, 2, 3, 4. Here I can call it as 4 sigma bonds. Always remember, the single bonds are always sigma bonds, and if it consists of double bond, in that one will be sigma bond, another one will be pi bond, right? So here if you observe, the carbon which is double bonded with oxygen is having 1 sigma bond as well as 1 pi bond. Therefore in carbonyl group, the carbon is sp2 hybridized. Since it is double bonded, it is sp2 hybridized. If it is single bonded, it is sp3 hybridized. Remember, the hybridization you already studied in first PUC. If it is single bonded, then it is called as sp3 hybridized carbon atom. If it is double bonded, it is generally called as sp2 hybridized carbon atom. Since it is sp2 hybridized, it consists of 3 single bonds, that is sigma bonds, and 1 is pi bond. And this bond angle, right? So this bond angle is a 120 degree. The bond angle in case of the carbon which is double bonded with oxygen, and here it is 2 single bonded with the alkyl group. So this bond angle, right? So this bond angle is 120 degree, right? So the bond angle in case of carbonyl group is 120 degree. And if you observe the structure here, this carbon double bonded with oxygen, and it is further it can bond with the 2 alkyl or aryl group. And if you observe this structure, right? So it looks like a trigonal structure, right? So it looks like a trigonal structure, and it is within the same plane, right? So therefore it is called as trigonal coplanar, right? So the structure of the molecule is trigonal coplanar, right? And here you can observe, so this carbon and oxygen double bond, here you can observe this carbon and oxygen double bond is polarized, right? So it's polarized, which means it breaks, right? So it can be separated due to the higher electronegativity of oxygen, which means oxygen consists of 2 lone pair of electrons. Always remember, oxygen consists of 2 lone pair of electrons even after the bond formation. So therefore it has capacity to extract the electrons from carbon. It has capacity to extract the electrons from carbon, and therefore the partial positive charge will be formed on carbon atom and partial negative charge will be formed on oxygen atom. So since oxygen is more electronegative, here I can show that one. So here if you observe, the carbon is double bonded with oxygen, and further it can be bonded with the 2 alkyl or aryl group, right? Since this oxygen is having the capacity of more electronegativity, so it can extract the electrons from carbon. It can extract the electrons from carbon. Then what happens? This carbon will be positively charged and this oxygen is negatively charged. This double bond breaks and these electrons are taken by the oxygen and it will convert into negative charge. and it may be converted into carbocation, right? So this is due to polarized, right? So this is polarized because of more electro, right? So that is of more electro negative oxygen, right? So oxygen is more electronegative when compared to carbon. So therefore what happens? So it breaks, right? So this bond breaks, and here the oxygen will get a negative charge and carbon will get a positive charge, right? So these are the four important, right? So information regarding to the structure of carbonyl group. So here if you observe, the first important thing is it consists of 3 sigma bonds. Along with that there is 1 pi bond, and due to the arrangement of atoms it will get 120 degree the bond angle in this, right? So that is 120 degree is nothing but a bond angle in case of carbonyl group, that is 120 degree, and the structure of molecule is trigonal coplanar, and the structure of molecule is trigonal coplanar. And here if you observe, the carbon is double bonded with oxygen and further single bonded with both the alkyl or aryl group. So this oxygen being more electronegative, since it is more electronegative, it has capacity to withdraw the electrons from carbon atom. Whenever it withdraw the electrons, so this double bond breaks. Therefore, whenever this double bond breaks, the oxygen will get a negative charge and carbon will get a positive charge. Therefore, so it can be polarized. The bond between oxygen and carbon is polarized, and oxygen will get a negative charge and carbon will get a positive charge, right? So these 4 points I have written here. If you observe the carbonyl carbon atom, that is sp2 hybridized, since it is double bond, it is a sp2 hybridized with a 3 sigma bond, as I have already explained, and it consists of 1 pi bond also, right? So generally with oxygen, and the bond angle is 120 degree, that also I have explained, and having the trigonal coplanar. Coplanar means they are all in the same plane, right? So trigonal, which in the, right? So the arrangement is mainly in the form of trigonal, right? So that is trigonal coplanar structure, and the carbon oxygen double bond is polarized, which means it is broken or divided due to the higher electronegativity, of oxygen, which is relative to the carbon, which is bonded with the carbon. Therefore here if you observe, the carbon double bonded with oxygen, right? So further, due to the higher electronegativity or more electronegativity oxygen which is present on carbon, it can extract the electron, or it can break this double bond, and it will convert into negative charge, and there will be a positive charge on the carbon atom, right? So that is all the information about the structure of carbonyl groups. Okay, once again we'll quickly recall what we have learned today, that is aldehydes, ketones and carboxylic acids. The main important and interesting thing about all these organic compounds or all these functional group is it consists of carbonyl group, but further attachment of carbonyl group to different kinds of molecules make them aldehydes, ketones and carboxylic acids, right? So in case of aldehydes, what happens? The carbonyl group which is bonded to the carbon and hydrogen, but in ketones it is bonded with the 2 carbon atoms, which may be alkyl or aryl, and in case of carboxylic acid, it is one side bonded with the alkyl or aryl group and another side it is bonded with the OH group, generally in the form of RCOOH. And this carbonyl compound, which is carbonyl group which is bonded with nitrogen, will generally call it as amide. If it is further bonded with halogen, it is called as acid halides, right? And general information and general uses of aldehydes, ketones and carboxylic acids are generally used for the biological process in plants and animals, and they add fragrance and flavor to the nature. They are used in the many food products and pharmaceuticals, in the manufacture of paints, additives, perfumes, plastic as well as fabrics also. And along with that, we have seen some of the important information regarding to the nomenclature of aldehydes and ketones. Generally in case of IUPAC, right? So they are generally called in terms of common name itself. More than the IUPAC name, the common name is preferred. And if you go for the IUPAC name, only one word you have to remember, that is ending letter E, ending alphabet E is replaced with AL in case of aldehydes, and it can be replaced with ONE, that is ON in case of ketones, right? So we have seen some of the important examples regarding with the common naming of aldehydes and ketones. Similarly, common name, that is IUPAC name of aldehydes as well as. And the last important part which we have studied today is the structure of carbonyl group, in which the carbon is double bonded with oxygen, this carbonyl group, and that 3 important points are, so the carbonyl carbon atom is sp2 hybridized, okay, and it consists of 3 sigma bond and 1 pi bond, and the bond angle is 120 degree. Due to 120 degree bond angle, it has a structure of trigonal coplanar, and due to the more electronegative oxygen which is present on a carbon, so it can polarize this bond, or they can break this bond, and negative charge will be present on oxygen and positive charge will be on the carbon atom, which means whenever it polarizes, the oxygen polarizes double bond, the carbon will get converted into carbocation, right? So that is the overall information about the structure of carbonyl groups, right? So in the next class, we'll continue with the physical properties, the chemical properties, as well as the uses of aldehydes and ketones. So we'll stop here, continue in the next class. Thank you.